Guys, welcome to learning microcontrollers. In this lecture we will be removing our very common confusion regarding the two formulas. One is the Ohm law, which states that V is equal to IR. This means that voltage is directly proportional to the current, while the other formula, that is the power formula, which states that P is equal to VI, which means that power is directly proportional to the product of voltage and current. This means that voltage is inversely proportional to current. So in case of Ohm's law, the V is directly proportional to I. This means if the voltage increases, the current increases. If the voltage decreases, the current decreases. While in case of the power formula, V is inversely proportional to the current, meaning that if the voltage increases, the current will decrease, and if the voltage increases, the current will increase. Why? Why they are opposite? Which one is correct? And when which one is correct and when which one is incorrect? Now this is our common question and a confusion. So let's get started. So guys, this is our power formula, which states that power is equal to voltage into current. So P is the power, V is the voltage, I is the current here. So voltage multiplied by current is equal to power in case of a DC circuit. Now if we do further math, we come to know that P is directly proportional to V if I is held constant, and this means if power increases, the voltage will also increase. And secondly, power is also directly proportional to current I, which means that if power increases, the current will also increase. If we do some simple algebra, P is equal to VI, I keep the P there, I bring the I here, so it will be a cross multiplication. It will be P over I is equal to V, or it can be written as voltage is equal to power over current. If I take the P to be a constant, this means if voltage increases, the power will also increase. While the second line, this is the confusion, the second line. This means if voltage increases, the current will decrease. While in case of the Ohm law, it states that voltage is equal to IR, which means that if the voltage increases, the current will increase. So this is inversely proportional. Like this, V is inversely proportional to I in case of the power formula. So let me tell you here, if you are a mathematician, you can easily understand the reason. Like V is equal to P over I. If we take P to be a constant, then we can use the proportional sign instead of the equal sign. So this is only true when power is constant. Now this is the reason why this formula will be V will be inversely proportional to current I only when the power is held constant. But as a mathematician, I can easily understand this. But as an electrical or an electronic engineer, we cannot understand this theory directly, how it is applied on the circuit. We need some simulation, some sort of circuit to understand. So I will be showing you a simulation soon. But first, let's get to the Ohm's law as well, little bit of description of the Ohm's law, then we will go for our simulation to clear the things. Now, this is the Ohm law, which states that voltage is equal to current into resistance. This means that voltage is directly proportional to current, and it is also directly proportional to resistance if one of the quantity is held constant. Now, first of all, V is the voltage, I is the current, R is the resistance. Further, V is equal to IR. This means that voltage is directly proportional to I if the resistance is held constant. Now, this is the problem, that in case of power formula, voltage is inversely proportional to I, while in case of the Ohm's law, the voltage is directly proportional to I. This means if voltage increases, the current will also increase. While in case of the power formula, it was the opposite. Then the second thing, if we held the current constant, then voltage is directly proportional to the resistance. This means if voltage increases, the resistance will also increase. But our concern is only the one formula. Now from the power formula, we got this equation, that voltage is inversely proportional to the current. But this is only true if power is held constant. And from the Ohm's law, we get this equation, V is directly proportional to I. The voltage will increase if the current will increase. The voltage will decrease if the current will decrease, only when resistance is held constant. Now these are the conditions, these two lines on the right. For the power formula to be true, it will only be applicable and will only give us the true results if the power is held constant. For the Ohm's law, it will only be true if the resistance is held constant. But as a mathematician, we can easily understand these things, like as a physicist. But as an electrical and electronic engineer, we need some sort of verification in the circuit. So let's do that. So let's open our circuit simulator. I will be using the Multisim Live. You can use the Proteus and other circuit simulators as well. So to open the Multisim Live, just go to your Google, write down Multisim Live. There you go. Click on the Multisim Live online circuit simulator. You have to log in with whatever the ID you made, And then once you log in, that this part will appear, create circuit, click on it. This window pops up. I also have a lecture on this, Introduction to Multisim Live. You can go through that lecture if you don't know how to sign up to this free software. It's a free software and works online. Okay, now first of all, let me open the magnifier so we can zoom in whenever required. So first of all, we need a load. So to get a load, go to the left. There you have these indicators. I will use a lamp as a load so I can adjust the power. I place it on the screen. Double click on the lamp to adjust its properties. Go to the right. There you have the properties. Now see the maximum rated voltage 12. I make it 10. The power, we will play with it, but right now the constant power is 10 watt. Burnout voltage 15 volt, no issue. Now the second thing that we will need for the simulation is a DC power source. Now go to the left. There you have these sources. You click on it. There you have the DC power source. You place it on your screen. Okay, I placed it here. Now we have the load and the power source as well. Connect them like this. From the other end, take it to the negative end of your power source like this. At the bottom, you need a ground. For every simulator, you need to connect the ground, else there can be problems. Just the negative side of both the lamp and the power source will go to the ground like this. Now our circuit is completed. Now we attach some meters. We need to calculate the voltage and current both. In this bar, analysis and annotation, select the voltage meter, and we measure the voltage across the bulb, positive here, negative here, like this. Okay, for the current, again, now this time instead of the voltage, select this current, this one. Measure the current anywhere on the circuit but in same direction, like this. Okay, this will be fine. Okay, we will have both the voltage and the current measured here. Or I think we should bring it here, so it do not, okay, that will be better. Okay, now what I do is that I run the simulation. Okay, when the applied voltage is 5 volt and the lamp is rated to be 10 volt and the maximum power of the lamp is 10 watt, then at 5 volt you can see the lamp is not fully bright. Okay, that's fine. This is supposed to be like this because we have not given it the maximum voltage. So if I increase the voltage, now as per the Ohm law, whatever the Ohm law says is that if the voltage increases, the current must increase. So if I go to the presentation, you can see that now this is the Ohm laws. As per the Ohm law, V is proportional to I only if the resistance is held constant. So in our case, you can see that there is no resistor, so resistance is held constant. Now it means that if the resistance is held constant, then this condition is true. So if we change the voltage, the current is supposed to change. So let's change the voltage and see what happens. Okay, I go there and I click this. Instead of 5 volt, I increase the voltage. Okay, it's decreased. I increase the voltage to 6, 7. Okay, now you can see that when I am increasing the voltage, see, I am increasing the voltage, the current is also increasing. Now I increase the voltage further. See, the voltage is now 8.9 volt. The current is now 890 milliampere. Now the voltage is 10 volt, the maximum that our bulb is rated for. So the current is now 1 ampere. Now if I lower down the voltage, I make it 5 volt, 2 volt. Now the point over here is that the voltage is increasing, so the current is also increasing. That is what the Ohm's laws say, because our resistance is constant. See, okay, so we have increased it too much, it might get burned. Okay, I increase the voltage. See, the voltage is being increased, the current is increasing accordingly. See, this is the current, this is the voltage. I am increasing the voltage, the current is also increasing. So this means the voltage is directly proportional to the current. Now we are now at the maximum voltage and maximum current. Now the next question arises, okay, we have verified the Ohm's law. Resistance is held constant, so the voltage is increasing, the current is also increasing. Now, as per the power formula, the current is supposed to decrease only when the power is held constant. Now we go to the power. I click on the bulb. On the right side, I told you we have the power. Now the power is rated to be 10 watt. Now the question arises over here is that why the current stopped at 1 ampere? Why the bulb only took 1 ampere at 10 volt? Because current is a drawn quantity. The load could have taken as much current as much it wanted. Why it stopped at 1 ampere? Because the rated power of the bulb is 10 watt. It cannot, the product of voltage and current, if you multiply 1 with 10, you get 10, because our rated power is 10 watt. See? Now, if I increase the rated power, okay, I stop the simulation. because the power will be constant. I change it to 30. I multiply the rated power by 3. Now see what happens. Okay, now when I change the rated power, the current has become 3 ampere. See, the voltage is same. Now if I multiply 10 with 3, I get 30 watt. See, 30. So this is what this formula means. So that is why the power, in case of the power formula, voltage is inversely proportional to the current. Why? Because if the power is held constant, if the power is 10 watt, then once the voltage is applied, we are the one who decide how much voltage is to be applied. The current is drawn by the quantity, and how much current is to be drawn depends upon the rated power of that load. So if the power of the load was 10 watt and the applied voltage is 10 volt, the current taken by that load will be 1 ampere. In case we made it 30 and the voltage is same, the 10 volt, it will automatically adjust to 3 to make it 30. So that is how it will work in inverse proportion to cater for the power. The power must be reached by the current. The maximum power as per the applied voltage will be reached by the current with the inverse proportion to the voltage. So that is what this means. Now suppose we stop the simulation again, we change the power again. I make the power 100 watt. Now see, I run the simulation. Now the current is automatically 10 ampere because the bulb is rated to be 100 watts. So 10 multiplied by 10, that will be the 100 ampere. So that is what happening here. If I change the voltage, now see, if I change the applied voltage, I lower down the voltage, the current also gets lowered down because now it is following the Ohm's law. Why? Because we have no resistance here. The resistance is held constant. So it is following the Ohm's law. But once we reach the maximum rating, okay, 10 ampere, 10 volt, then the current adjusts automatically to cater for the maximum power because we are not taking resistance into account. So they will be the exact values. So 10 multiplied by 10, it will be 100 watt. So I change the power again. I lower down the power to 65. Now it is 6.5 ampere at 10 volt. So simple guys, this is how it works. So I hope guys you understood how these both formulas work. When this is applicable and when this is applicable, they both work together. Ohm law is everywhere. And this also becomes valid when the power is being drawn by a quantity, a load, depends upon the rating of the load. So in every case we have a motor, we have any device, any machine, it is drawing power, then we must know that when the voltage will be inversely proportional to the current and when the voltage is directly proportional to the current I. So guys, this is it. I hope you guys learned something from this lecture. If you have any questions, please do ask. We'll see you in the next lecture. Goodbye until then.